Hello friends, today I'm going to solve LeetCode problem number 62, unique paths. So we are given an m by n grid and we need to find the number of moves from top left corner to the bottom right corner, and from each cell we could only move towards the right or down. So there are only two possible moves we could make, and then I mean that two possible directions we could move in, and we need to find out the number of ways we could reach the finish cell from the start cell, which the start cell is actually the first cell at grid number 00, and the last finish cell is the cell at grid m-1 and -1. So how could we solve this problem? Let me show you here. So we are given a grid, and from start we need to reach the end or the finish. So there are only two ways we could move from any given cell here. So from this we could either move in this direction from this one, or for this from this cell I can go in this direction or in this direction. So from this one I cannot go towards right because then I'll go beyond the grid. So for this I can only go down, and similarly for this I can only go down. So here I've already found one path, and now for this one I can go this way and this way. So I found another path here, and similarly for this one, when I go towards the right I found my next path. So in this way there are multiple ways. There are ways we could reach our end. So now we need to find how many ways we could actually reach our end. So let's divide our problem into sub problems. So the whole grid I divide it into sub problem, and the sub problem is that for me to reach from start to end I need to reach the node, this node and this node, because only then I can reach end, right? So so from this node how many ways can I reach end? We're only one, so there's only one possibility I can reach the end node. Let me use black here. So there is only one way I can reach. Okay, black is not good. Let me use blue. So only one way I can reach the end. Similarly for this, there is only one way I can reach the end, right? So for how many ways from this node or this cell can I reach end? Well, I can go this path or this path. So the total number of paths is equals to 2. What about this node? I can only go this path. I cannot go here because then I'll exit the boundary of the grid, so which is only one path here, so the value would be 1. What about okay, let me use red for this. So for here I can go in this two direction. From this I can go either here or here. From this I can only go in this direction. So yes, so from here also I only have one direction I can move, which is in this direction to reach my end or finish. So it's only one. From here also it's only one way I can reach my end. Now what about this? In how many ways can I reach my finish line? Well, it is a value 3. One is from here and the two paths are from here this way. So basically I am adding the number of ways I can reach my node from here plus the number of ways I can reach my end node from here to find the number of ways I reach my finish from this value. So what are we doing is we are just adding the paths to find our path to reach the end. So for this we'll add 3 and 3, which is equals to 6. For this I'll add 3 and 1, which is equals to 4. So finally the start value will be 10. So I can reach my end in 10 ways. So let me create a dynamic programming DP array of length m, and for let I equals to 0, I is less than m, I plus plus, it should be a 2 to the array DP I equals to new array of length n, and I'm gonna fill them all with value 0. And now for the end, if we reach our end, how many ways is there to reach end from end? Well, basically it's 1 here. To reach end from our end node, we only have to traverse 1 node. We only need 1 move. So this will be our H condition here. So dp m minus 1 n minus 1 equals to 1. And then now we start our traversal from, okay, so let me define my DFS equals to function and then in DFS, what do I need? So in DFS, I'm traversing a new path, right? So I need the value of the cell, and then if I need to check the condition, if I is greater than or equals to m, or j is greater than or equals to n, which is an invalid case because we are crossing the boundary, we return 0. And then what are we gonna do next is we find the value of our dp ij. So before that, we also need to check if we already have the value of the dp, that is, it is not equals to 0, then we're just going to return our dp. We don't want to keep calculating the same thing again and again. If we do not have, that is when we then find the values for that dp. So now I can either move to down, which is I plus 1 comma j, or I can move towards right, which is I comma j plus 1. So I can move in either of these two directions, and the value of these and these, the sum of these two values will be the value of my path on that cell, right? And then I'm going to return my value at dp, and finally I'm gonna call my dfs function at my starting point, and then return the value that is returned from this one. Now let's run our code. So talking about the time complexity, since we are traversing each of the nodes here, right? Yeah, so we are moving from each node. So we are every time from one node I'm going to the left, so I'm going from here, I'm going here, from here I'm going here and here, from here I'm going here and here, from here I'm also going here. So every time I'm moving each of the nodes. So basically it is every time I'm calling my df as n number of times, not every time, but I'm calling the DFS in total n number of times, n times m number of times. So the time complexity will be m by n, m times n. Okay, if there is anything that you would want to tell me, please comment on comment down Okay, if there is anything that you would want me to know, or if you have any concern regarding my solution, then please let me know in the comments below.